So we're going to continue our review for our final. The next example we're going to look at is evaluate the integral cosine to the fourth. Now remember I said there were rules about your powers for sines and cosines. So if our powers are positive, if m and n are even, then we need to use our double angle formulas. So we're going to take this cosine to the fourth and rewrite it as cosine squared squared. And then there was a formula for this cosine squared based on the double angle formulas. So it's 1 plus cosine of 2x over 2. And we're going to square that. So you'll get a 1/4. 1 plus cosine of 2x squared. And now for this, again, you need to FOIL that out. Expand it. And you'll get 1 plus 2 cosine of 2x plus cosine squared and I know how to integrate 1. I know how to integrate cosine of 2x. You would do a substitution. But if you look on this last one right here, the power is even. So we're going to have to use our formula again that we used earlier. 1 plus 2 cosine of 2x, and this will be plus 1/2, 1 plus cosine, and make sure to double it, so it would be 4x now. So I'm going to simplify this a little bit. Inside of my integral, I'm going to combine this 1, and then this is really 3/2, so it'll be 3/2 plus 2 cosine of 2x plus cosine of 4x over 2. And now I'm finally ready to compute this integral. Do the finishing steps. This will be 3/2 x plus sine of 2x plus 1/8 sine of 4x plus c. So anytime you have even powers on both sines and cosines, you're going to have to use those double angle formulas. So the next trig integral we looked at was tangent to a power and secant to a power. And remember, it's separated off into two different procedures based on if n is even or m is odd. I'm not going to go over those two different methods. We're just going to look at some examples here. So let's say I want you to evaluate the integral of tangent to the fourth and secant to the fourth. So if I look, my power of secant here is even. So it breaks down into this first rule right here, if n is even. So what you're going to do is you're going to separate off two of them. Tangent to the fourth, secant to the fourth. You're going to break it up as tangent to the fourth. Remove 2 of the secant, so you'll have secant squared and an extra secant squared at the end. And then you're going to take the remaining secant squareds, which is that one, and rewrite it in terms of tangent. So this is going to be 1 plus tangent squared. And now we can just do a u substitution. Our u would be tangent. The derivative of tangent is secant squared. So I'm going to get u to the 4th, 1 plus u squared du. So you just need to get rid of the multiplication by distributing. And then you have a polynomial, do the reverse power rule. And don't forget the plus c, and then plug back in. So this would be tangent to the 5th over 5 plus tangent to the 7th over 7 plus c. So let's look at another example with tangents and secants in it. Let's evaluate the integral of tangent cubed theta secant to the 5th theta. So now my power of secant is not even, but my power of tangent is odd. So we're going to take our integral and we're going to separate off both a tangent and a secant. So it'll be tangent squared secant to the 4th. And then off to the side, we'll have a tangent and a secant. So now what we're going to do is take this tangent squared and write it in terms of secant. It's secant squared minus 1. And now again I can do a substitution, but this time my substitution will be on secant theta, whose derivative is secant times tangent. So for my substitution, I'll get u squared minus 1, u to the 4th du. Again, get rid of the multiplication by distributing. And then do your reverse power rule. And plug back in for u. It was secant theta, secant to the 7th over 7 minus secant to the 5th over 5 plus c. So let's do one final trig integral here. So let's recall that the integral of secant x is ln secant plus tangent. So the example we're going to look at, I want you to find the integral of secant cubed. Now this integral doesn't fit into either one of our rules because the power of secant is not even and there's no tangent, so the power of tangent isn't odd. And so the way we're going to do this is we're going to split secant cubed up into secant times secant squared and use integration by parts. So my u will be secant x, my dv will be secant squared. So secant times tangent, and then the integral of secant squared is tangent. Go across and down. So the integral of secant cubed will be secant times tangent minus the integral of secant tangent squared So now we use our formula for tangent squared and write this as minus secant, and then this will be secant squared minus 1. Okay, so the integral of secant cubed, secant x tangent x, and then let's split this up. So this will be secant cubed, and then split it up into two integrals, plus the integral of secant. But I know the integral of secant. That was our recall fact from I did at the beginning of this problem. So the integral of secant, it was ln secant x plus tangent x. And if you look, the only integral that remains is actually the integral we started with, but it has a minus in the front. So what we're going to do is we're going to treat this like an equation, which it is, and add it to the other side. So when I add it over here, I will now have two of them. And it's secant times tangent plus ln of secant plus tangent. So you just divide everything by 2 and you'll have your answer, but there is one thing you need to remember to add. You need to remember to add the plus cn. Secant x plus tangent x plus c. And there's my answer.